Good evening, everyone. Let them continue coming. You can also start typing in any questions that you might have had in the chat. Good evening, everyone. Welcome to today's onboarding session. My name is Dr. Kibaso Raymond Sianyo. I'm the founder and CEO of Rastuc Technologies Limited, and we are very pleased that you have spared some time to join us today. Feel free to interact with us as much as possible. Today's session is intended to be for an interaction and an introduction to those who have never heard about Rastuc Academy and other Rastuc initiatives, and also a way of us knowing the character of the students that we are having to on board, so that we can know how to collaborate and how to pair you up with the various industry professionals and business innovators that might need to partner with you so that they can make your ideas into fruition. So without further ado, I'd like to introduce Mr. Jacob to take over the next part of this session. I'll be monitoring the chat session and on the WhatsApp platforms in case there are any inquiries that might arise as he's presenting, so that we can be able to address them all. Thank you so much.
Hello, everyone. I'm Kebaso Jacob. I'm the ML lead for this summer school. I'll be guiding you through what you're going to cover for this curriculum, how it's going to run, and whatever you can expect afterwards. Maybe as we proceed, if you have any further questions, you can leave them on the chat, and then we have a Q&A session at the end. For bandwidth preservation purposes, I'll turn off my camera so that we can proceed without any impedances. Okay. Okay. So a little bit about the Rastuc AI School. The Rastuc summer school emerged from we wanted to teach people, or rather bring people on board to this AI industrial revolution of some sort, because AI is already here to stay. It's here. We can not try to think that we can now outlive it or some kind of leave it as a by the way. It is here to stay with us, so we might as well adapt to it, because okay, as the physicists have put it out there, is that the only constant is change. So the journey, we started with the first 2 cohorts. Initially, we called it the 100 Days of ML Challenge. From that name, you can see that it was a compact program, which was more or less straight to 100 days. All the content, we have fixed it and merging it into a 100 days program. In that program, we focused on rapid and intensive learning. Everything we are bombarding together for that limited time. We provided a strong foundation of ML fundamentals. We have had some of our alumni, and I think I will not mention the name for now, but he'll be joining as a guest speaker later. Is doing now health informatics, IT in health informatics. Okay. Now, why did we evolve to calling it now the summer school? Many reasons. The first bit, we realized that those 100 days were not really auguring well with the students. Most of our students benefited from a more spacious learning timeline. You see, you are compacting 100 machine learning fundamentals and everything there is about ML in 100 days to, let's say, a class might have engineering students. We have medical doctors in our midst. We have postgrad students also. So we have people from different backgrounds. If you are to compact everything together in that short time period, people might have experienced a lot of hardships, we can say that. So we expanded the timeline, added some more time to this challenge. So a practical application needs more hands-on, which will be our focus on this summer school. We have curated a lot of hands-on projects. I'm assuming, as with any other field in medicine, engineering, you are doing programming of some sort, or you are trying to master your skills in surgery, you need a lot of practice. Every practice tends to make you even more and much better. So that's the philosophy we will employ in this cohort. There'll be a lot of exercise for you guys to work on. There'll be concepts, complex concepts require deeper exploration. We are assuming, let's say we are going to teach example, something about convoluted neural networks. How we are going to approach this bit is that we are going first, we give you the objective. Why should you care about learning the machine, that convoluted neural networks? What are they? What inspired? I think from what I've discovered from my doctors, my friends who are doctors, they get to understand, okay, they can diagnose a patient more supremely if they get a little bit of history. They do the clinical history, then from there they can get to give a better diagnosis. In the same case, you're building a community and collaboration which deserves a dedicated focus. Okay, so in this new vision on the summer school of 2025, we have revised the curriculum by incorporating feedback that we have gotten from industry. We have a lot, some of our facilitators in the first and second course chipped in the creation of this third iteration of the curriculum. We have focused on the practical applications. We have extended the duration. Initially, it was just 100 days. Now, after we have gotten that kind of feedback, we are stretching to 4 months now. There will be a stronger emphasis on the project. So learning will be hands-on, which is more focused on the project. We give you a problem, then from there you can work your way around it to reinforcing the critical point you want to put across. There'll be more opportunities for mentorship and peer collaboration. So what should we expect to have learned from us at the end of this summer school? After 4 months, what would success be for us and to you? As the participant in this summer school, we expect, number one, for you to have get technical mastery. We will not assume that everyone is tech privy here. We have from different backgrounds. We have consultants here, we have doctors, we have engineering students, we have engineers in the field. So we have structured in a manner that everyone gets a little bit of an intro of a new kind of space. So for the technical mastery, you're going to master the foundational and advanced ML concepts. You develop the proficiency in essential AI and ML tools. We are going to teach you a lot of frameworks. Okay, for an example, we expect that at the end of the summer school, we are going to have a capstone project. Maybe I can touch on it. Everyone here is going to, at the end of the program, will have created a solution from scratch, written the code, developed it, train your model, and then we'll teach you how to deploy it so that people out there can actually use your model. Instead, okay, there's this familiar joke in for the computer science and the engineering fields where you have a junior dev and a senior dev. Then the junior dev has written some solid code, it's working on his computer, but that has not yet been shipped. Then the senior developer is like, okay, so can't you say there's a problem here? Then the junior developer is like, but it works on my laptop. So the senior developer is like, so should we give every other customer your laptop? That's what we're going to do here. We are going to teach you so that you have made it on your laptop. Then you have to, how can you get it to the market out there for everyone to actually use it? Now we will teach you production ready skills. Most of what happens around people who tend to pursue this ML field is that they are doing a lot of, okay, let's say you get a project, you do it on your computer, it works 90% accuracy, you're good to go. But there's a difference between creating a highly performing model on your own PC. Then there's another difference of a model working out there suitably. There's a lot that happens between your model on your laptop and getting it out there to production to the people. So we'll also teach you that. Create user-facing AI applications that are accessible to the general public. Then there's something you're seeing here. There's the master MLOps practices and deployment patterns. That's basically what you're going to, you can imagine, let me give you an example of that. Every time you see that Amazon there's a recommender system at the Amazon stores when you're going to book something, okay, buy something online, they get to learn your preferences over time. So you see, there has to be some kind of continuous learning for the model. It cannot be like it has just been deployed once and it serves for 100 years. That's now not even, now that's back to rote programming now, if and else statements. It's supposed to be actively learning. So we'll teach you something we call the pipeline. So you are continuously improving the model with new data. Today you have clicked on some electronic. Tomorrow you come electronic. Then another time you come, now you're searching for books. So you should learn that this guy is more oriented to electronics and maybe he's a reader. He loves reading. So those kind of pipelines, continue creating those continuous pipelines. Then for the professional development, you are going to build a portfolio of real world AI projects. There's another joke we have had that for, maybe you've seen it somewhere, that a guy got into programming and he wrote the first word, print hello world. Then is out there on the CV, big data, machine learning, and such robotics and everything. You see that kind of jokes there. You have seen even companies there was some story going around that the Meta CEO, these days how they kind of look at the paper you have published out there, you normally leave your email there. So the guy inboxes you with a job offer. In our case, we'll prefer you that you're going to maybe apply somewhere for some ML-oriented opportunity. We prefer that you give them a portfolio of your project that you have worked on rather than a well-furnished CV. Okay, it's good to have that one, but a portfolio of solid projects will get you much further. Then we develop your machine problem-solving skills through practical challenges. Most of the physical sample projects are going to work in this case is real-world data sets. we'll take real world data set. Okay, I cannot say them. We vectorize up them on with some sort of scrapping, so that we anonymize the data. Let's say that way, yeah, so that you can actually work on them. Then we give you industry, a defined industry approach, a kind of how do I put it? Okay, industry readiness. Let's just go with it. You get to understand how the AI product development life cycle works. Normally, people tend to say, okay, it's the de facto idea of how the ML development life cycle works, that as long as you have the data as the starting point. But really, the starting point is knowing, is this problem solvable without incorporating ML? It's more like saying ML-powered Smocha or ML-powered lemon tea. There are some things that really don't need sprinkled with ML every other time you need to solve them. There are some things that can be solved with the normal programming. ML, the state of ML we are right now, we call it Web 3.0. Okay, we can say it that way. Then there's the Web 1.0, Web 2, where we are programming for the programmers, where you, let's say example, you want to code something, you wrotely hard code the instructions how you want to perform. This is the software programming 2.0. But for machine learning, we are in 3.0. Okay, assuming you want to cook some spicy chicken, you for the normal traditional programming, you come with now cut that chicken, marinate it, cook it. Okay, switch on the cooker, add water, put it in the sufuria, and so on. But for ML, you're supposed to come, give there's the chicken here, the uncooked chicken and some ingredients. Then if on its own, it should figure out that, this is how I should go. Okay, this is the chicken and the ingredients, and this is the expected output. Then it figures it on its own, what it should do to give you that desired output. Then we also be having some guests, mostly will be giving us the entrepreneurial mindset with regards to AI. Then there's this bit where, there's this joke here. I think will come further when you are getting further into the program. We teach you some hacks on documenting and maintaining good code, which will be very primal for our case, because we're also trying to reinforce the bit about open science. These days, even NASA, there's a program they're running. I think I'll share the link later so that you guys can also exploit. It's called NASA Talks, where this NASA towards open science. They are trying to embrace this bit about open source things, where do your stuff, then at least try to share it, collaborate with other out there, so that people can actually try to iterate. And the more we iterate, some guy comes with an idea, it's iteratable, you work on it, you advance it faster. We get to advance as a whole. Then community and network, we collaborate with peers on meaningful projects. For the engineers here, we have doctors here, very brilliant doctors in our midst, who might be having projects they might want to work on, but you see, it's this the purpose that you might find that this is a neurosurgeon. It's also an affair, I guess, a talking theater. Then again, start learning HTML from scratch again. Yet you guys are here, so we are trying to create a community to fast track the rate of execution in this place. This guy is very proficient in the surgery theater and so on, where you can collaborate to bring his idea quickly out here instead of now as a tenor from scratch. Yeah. Then you will be among our last alumni network, and inside the program, once you make some products, we'll be sharing with you so that you guys can try to better test it with us. Then I think we'll be having guest speakers with us who will be both in the medical, engineering, finance, entrepreneurship kind of industry, where they are applying, even research and academia, where they're applying AI to switch us further. Okay, maybe not every one of us might be well excited about, in addition to the portfolio project that we are going to create, there's need to have some kind of certification on Arusha LinkedIn. This is an example of one of our alumni. We we be issuing out once on the completion of this summer school, there'll be a certification that you can share to LinkedIn, Twitter, and whichever platform out there you would prefer to. So our curriculum, we have modeled it into 6 phases. The first phase, we, as I mentioned before, and this program, we are very critical in having everyone on board. We do not assume that everyone has had an encounter with programming before. So we're going to have the foundational, like you see, we'll have the Python basics, the programming fundamentals and logic, the Git, okay, the version control on how to use Git and GitHub, the software development best practices, okay, object-oriented programming. Those we'll dive into later. Then afterwards, after we are done with that, now that everyone at least would have been, when we are talking about variables, it does not seem like a very new, okay, foreign term. It's as if, okay, it's like me. If I get to a medical class and people are talking about sarcomas, that's really seemed like some Martian terms and so on. So after phase 1, we'll be talking about function, and then at least to be making sense to everyone on board. We'll be speaking the same language. Now then, we can now start getting near to our full purpose here, the data analysis with Python now. We have decided to use Python because of obvious reasons. Most of us here will, okay, one reason other than for use case to use it for ML. Some guys might prefer to, okay, now I've learned how to deploy the machine learning model I've created and everything. Even if I don't have access to other developers, you can, now that you have gotten a foundational understanding of Python, you can move to the web development frameworks if you want to go that way. We have you can go do Django, Flask, then you can be very fully, okay, we can say you're a full stack ML engineer in this order, where you can create your model and also create the site and everything else. Get it running, you even create the user-facing AI interface and so on. Okay, then on data analysis, with Python, we're going to study the scientific computing libraries under Python, where is the NumPy, Pandas, exploring data analysis, EDA. Oh, okay, Matplotlib again. We'll see how you can do data cleaning. We'll teach you, okay, there's the big data you have had there. We'll teach you some of those tools that are commonly used there. We have the Apache SpicePack. Okay. Mostly this is what works around there. We have even the ML lib for the distributed machine learning. We'll even, okay, we'll see later how you're going to structure this program so that you can see how this is going to factor in. For the ML engineers here, there's okay, for the engineering students, there's something we call TinyML, where you can train your model and then take that model and embed it into hardware. It's more or less, okay, as an example, as an obvious example, we have Siri, you have, okay, Siri, Alexa, those things. You train a model and you deploy it on the hardware. It seems like a joke, but people now, there's a program running currently on Kenya Space Agency, and the Star Vision is a Chinese company. They actually made the hardware. Now they are trying to teach Kenyan students in partnership with other guys from Korea and so on to create, okay, they're building capacity for students to create those algorithms. Then they take those algorithms and deploy them. I think in the group I also share once those, okay, the algorithm and the satellite has been sent to the orbit, then we can work along it. Okay, then we'll go to the machine learning foundations. Basically here we'll talk about the linear regressions, the basics about machine learning, the supervised learning, semi-supervised, unsupervised, and so on. Then we'll get to the advanced machine learning concepts. By then, I think we'll have garnered a lot of confidence from the machine learning foundation, so that once we start on these hardcore things, it makes sense. Because, okay, for the ML fundamentals, advanced machine learning, basically what we'll be doing is we'll be teaching you most of the tricks now. Now this is where we dive into the ML ops, how you can get your model from production. Because in phase 3, you would have learned the foundations, fundamentals, and everything towards it. Then in phase 4, now we start introducing you to getting that machine learning model of yours, okay, or AI product shipping it to the market now, how you can deploy it out there, get it production ready, and so on. Okay, then in phase 5 now we'll get to the neural networks and deep learning, because now I think up to this point you'll be now hot. You'll be in a very hot content will be super for you guys. Then I think for phase 6, now we do some 2 bit of specialization tracks. Now maybe I can talk about what is computer vision and NLP. I'll not branch much further into it so that I don't get you fearful. But as an example, NLP, you can say it's ChatGPT. You fill that prompt with your nonsense, Kiswahili or English and so on, then it processes it and you realize, funnily enough, that it gives you actually a solid answer instead. So natural language processing, it tries to understand how you and I would have talked and give you solid results. Then for computer vision, it's basically, you can say, in quotes, it's image processing. This more or less works with the images, the image segmentations. We have, okay, I don't know how we can go about that. Satellite imaging. Let me give you an example of something maybe I've worked on. We have satellite imagery. We have the Sentinel, Landsat. They have gone there, taken images from there. Now we are trying to create a model where we can maybe say if they have taken pictures of the Nairobi, we want to just classify if it is that a car or a rolly or what, a trolley, what, a cat, and so on. So you get to annotate those things and create your model. Basically, this is a track that will focus on working with images. Let me simply put that way. Then NLP about here is where we'll see about those things about large language models, transformers, and so on. Maybe I might be talking about transformers. Don't be worried. We'll explore that. Then, as we close the cohort, everyone will work on a capstone project, which I prefer that maybe after the meeting you can share the kind of wild ideas of yours that you have, that you have always wanted to explore. Share it out there. We can even pick and from there and sort you out. You get teams who are even, you might be surprised that you get guys who are actually interested in working the same thing, which is, I was in some, okay, that's a story for another day. Okay. Yeah. So sample projects on what we are going to work on. There's the common, we do the common introductory projects to machine learning where we will be teaching about how to classify. There's a common universal dataset intro to ML. It's called the Iris dataset, where you get to classify flowers. Then there's the MNIST dataset where you are going to maybe classify this data, a sneaker or a shoe or something like that. And then the other, we said we are going to work on real world projects. Now, for example, for the doctors in our midst, they may want to work on a patient readmission prediction model. Once we start on the specialization tracks, this will be under the natural language processing. There is what we call the large language models. As an example, there's one we call the clinical BAT. This large language model has been trained on, we can say even 13 billion parameters. We explore those jargons, later. Basically, this one, how do I put it? It has been trained on medical terminology, clinical notes, hospital notes, nurses, okay, temporal, and basically PubMed and everything there is about that. So what it does is that it gets the temporal relationships in patient histories. It can see what the clinical indicators in what the doctor wrote in his notes, so that it can determine, okay, this guy, we have released him, but based on what the doctor had in his notes, there's a possibility that maybe 30 days later, they will be having a recurrent incidence of this guy getting readmitted again. Then we have the document OCR, or that's OCR in full, stands for Object Character Recognition and Information Extraction. You see, this bit about OCR is very easy if it's having a typed thing. I think maybe to give you what that stands for, OCR, for you guys who have worked with, you are going to Google, you are going to search something, there's that bit you have seen about Google Lens. Basically, that's a sample of what OCR is. That's like you take a picture, you can scrap of, you can select on the text and search it. So in this case, we'll get to work on handwritten one. I tried a sample example of a doctor who gave me a sample to test on this, and that handwriting, okay, not to sound, you know what I mean. For those guys, you have seen those memes, doctors and pharmacists, those signatures there, they know how they have their individual Morse code, how they communicate. You in the intermediate there, you can't get to see everything. So we can actually get that, guys can get to extract it. As an example, you're going to the hospital for the doctors, let's say, for how to digitize the practice, for example, those patient files, instead of now having to, let's say you are moving from those files to a digital version, instead of you having then going to type everything, oh, patient Joseph Kamau, then you're going there to type or presenting illness or something, then you're going to type manually from there. Come your camera, take that photo, OCR, the model runs it, influences there, picks up the details, then stored in a well-structured format in a database somewhere. Okay, then the language translation system, maybe for the doctors, okay, this can apply to everyone, so that most of this, you can create a system where guys don't have to, the language should not be the barrier. Your shosho or your grandpa at home there should not be able to, should not be impeded to access some services because of, okay, maybe a Kiswahili or English. So that language should be able to, okay, understand ameongea Kamba, then inferences to, okay, what does it translate to Kiswahili or English? They have been, so that it does that. Language should not be the barrier for that case. For the agricultural crop yield prediction system, you can have, okay, this is more applicable for if you're using satellite images, is you can see, okay, the satellite, okay, normally, if it's orbiting, it can be coming back to it every 90 minutes. It's orbiting for, that's current. You can see over time, as it orbits, you can see the crop mapping, the vegetative index as it's growing and so on. You can actually see, you can even predict how it's going to, the yields out throughput. Then we have the care discovery system. Patient, okay, maybe I can say this is what Rastuc has worked on. We have an AI model where you just go there, describe your symptoms. Okay, I've been riding a bicycle and I've fallen down, I feel my leg hurts. Then it gets to recommend, okay, based on those are bone issues, you can maybe see an orthopedic surgeon of some sort. Then it recommends an orthopedic surgeon for you. Then we have a diagnosis assistant. Maybe case in point. I think this will come as an illustration when you're going to use those tools in our learning. There's something we call, maybe you can say, when you're coding, there's some kind of, or how can I say, some words that, okay, maybe let's not even approach to coding. You are typing some, okay, even email. I wish this finds you well. By virtue that you have started dear sir, and you're, I wish, you get some some kind of suggested throughput there on what you can have as the next statement of some sort. So really, it does not tell you exactly what that is. You can have something that, okay, these patients have presented this kind of illness. Consider asking some of these questions. If you realize that it's a sorted of some sort, then this is the probable diagnosis. And then it presents you with the percentages of what might likely be that disease or illness that patient is suffering from. Then you as the doctor gets to choose what to diagnose on your own. Then we have this antibiotic stewardship program, maybe for the non-medics in the house. Maybe for this is a program that basically just promotes appropriate antibiotic use, where you're just trying to improve the patient outcomes while you are just minimizing the antibiotic resistance. They are resistant to antibiotics. Okay, so you're wondering maybe how can this work with how can you model it in machine learning? You just get to monitor how the patterns of how this kind of these antibiotics are prescribed, the infection trends, and even maybe the resistance patterns. It's all about the patterns. Then we can have the precision farming solutions. Okay, the same agriculture. We can have urban planning. You can see how the population, the movement of people has been going, the trends in them. Okay, urban areas. You can see the city analysis where in 2022, this was how the land coverage was. Now it's in 2022, you can see a lot of buildings have come up. Then we have the disaster management and many more. Disaster, okay, the satellite can see, okay, there's a fire or something. There's okay, it's a satellite layer there, assume that you can see how the weather patterns, the butterfly effect and so on is affecting the climate. Okay, then to the crucial points, other than the curriculum on what we're going to gain, now we have the necessary requirements. There's the price for the 4 months cohort. You're going to pay 30,000. Okay, for our friends outside the country, that's around USD 233. Then for the program, it's going to run for 4 months. We'll be having 5 sessions per week. That's Monday, Tuesday, Wednesday, Thursday, Friday. But does that not mean that for Saturday and Sunday we will be switching off our phones on this end and going airplane mode? It generally means that for these 5 days, these are the formal recognized days where we require you to be actively engaged with us. Otherwise, for the remaining Saturday, Sunday, you can just reach out in case you have any challenges, you're working something you want us to share, you collaborate, you reach out. Then time, we at least 2 hours per day. There's that at least was intentional. It means that out of the 24 hours, minimum 2 hours. It can be more. We tentatively, we have it that we'll be having the general sessions together for the field. We can call them the lab sessions where we're getting hands-on. I'll be showing you an example of the kind of resources we'll be using as we go through the curriculum. From 2 to 4, we'll be having some technical sessions. Let's say you want to get those deep dive, the hardcore, how the Google way, about you can say the OpenAI way of some sort. We'll be doing those hardcore. Then from 6 to 8 p.m. we have these general sessions there. Then for every other endeavor that we're going to do to learn or something, you will prefer, your curiosity is what will get you get you to gain mastery. Be curious out there, ask those questions. Everyone is a student here. If you find yourself that you're maybe shy, not ready to ask them in public, we'll be sharing my contacts will be there and the team, the Java and other facilitators. You just get in touch with them, ask those things. If you find some other resources out there that you prefer other guys to learn about them, just throw them our way. People here are very excited by virtue that you are all here. You have set time aside to attend this session. You are very excited about this. So find those resources, put them together, send them on our way. Okay. Before this, we start on this, I wanted to just tell one of our facilitators to say hi, Javan. Maybe you can say hi to our team. Sorry, Javan, are you around? Okay, I think just left me a note. Let's proceed. I think it'll come at the end. I think he's sorting out something. Okay, then up to that point, I'll open up the floor to any questions that you guys might have with regards to the program. Feel free to, you can raise your hand or unmute to inquire. Yes, Mr. Jack. Yes, Mr. Jack, you can go on.
Oh, yeah, sorry, I was on mute. I was saying, thank you for the presentation. If somebody misses a class because of being in other engagements, is it possible, will the classes be recorded and shared, or how does somebody make up for that?
Oh, okay. Missed class and recordings. Okay. For each and every other session that we'll be having under under the calendar of this cohort, everything will be recorded, so that maybe what might be a little bit slow because of processing and so on, we might simply put every record. There will be recording for every session that we are having here. Then we can share them with you later. Yeah. Okay. Yes, Mr. Andrew.
Okay. Hi everyone.
Hello.
Yeah. So my question is, so for this breakdown that you've given us, I understand for the purposes of this presentation, it is quite superficial. It's just touching on the layout. But as you said, most of us are from different backgrounds and we might be at different levels of skill. Some of us maybe have tried to program on the side, even those of maybe even medics have tried. But do you have a more detailed program, at least maybe for the first part, so that maybe someone can pace themselves? Not with an intention of skipping the some of the hours, but maybe you can pace yourself according to what you've been doing and what you're being taught.
Okay, I get you. Okay, maybe with regards to that, I can share another screen so that I can show you the. Okay, I'm on. Okay, there you go. Okay, let me fetch it. A moment. I presume you can see this. Maybe you can.
Okay.
Okay. So this is the intended bit. On this
Hello,
first.
Mr. Jacob, you have extended the screen, so you
Okay.
can pull the browser to the second screen.
Okay, sorry. Okay. Okay. No. That's nice. Okay, maybe I can. Okay. So on this foundation phase, we'll be having a little bit of history about what is programming and everything there is. Then we do the version control, how we'll be collaborating. Basically, this first bit, if you are going to maybe very held up, maybe I prefer this first bit is a little bit of essential because most of even the code submission that we're making for us to review to help you out, we are going to do it via GitHub. So this will teach you about Git and GitHub. Then we proceed the Python programming. Okay, this bit here. We do a little bit of introduction. Then we go through the whole language. You will see. We'll give you a history about what programming and why Python and so on. Then for Python and data analysis, you can see this bit. We have for data analysis, we'll be having three things. We have the NumPy. This is the content with regards to it. Then we have pandas. Okay. Then we have for the data visualization bit. We have this as the main thing. By virtue that there are many data visualization kind of tools that you can have to work your way around it. We'll be exposing you to many of them so that you get to choose. But the most common one will be the matplotlib, and maybe probably let's say I'll focus more on that. Then you get to know that there are other than matplotlib. You can explore this on your own. Then for the ML foundations, we introduce you to machine learning, where we show you on the subtopics, we have this bit, the supervised and supervised reinforcement, how to work your way around data processing and so on. Then maybe you will get to appreciate a lot of neural networks, and this bit later you see there's that bit about reinforcement learning, transfer learning, For the specialization track, there are some, okay. For the neural networks, let's just say that you'll see we'll be talking about things like activation function, loss functions, and so on. Then I think that's why for this cohort, we have introduced this bit. There's some bit of mathematics here. We have the linear algebra. You're going to see for the neural networks, basically, you will have to understand matrices and eigenvalues, okay, and such stuff, because that's how for the image processing, computer vision, so on, it's just more or less matrices here, in decomposing them, inversing, and so on. Then we have added some bit about, okay, this seems very complex terms, but until you get to see them under the hood, you see that these are just simple things. Then we see probability, because really ML is all about probability. It's a word of probability. It's like more or less quantum physics of some sort. It's a word of probabilities. There's 1 or 0 somewhere there. Okay, then we have some bit of statistics. We introduce you to some bit of maximum likelihood estimation. How is it going to predict on that? On what basis is there about? Then some bit of decision theory, which is relevant to machine learning. You see, decision theory applies to a lot of other fields, but in our case, we're going to bring it to the aspect to how do those models make decisions? How do they choose the right model to present to you? Okay, maybe as an example, okay, best practices, we see that when you're training something, you have like, maybe you can see this, I can work on this with linear regression model, I can use a neural networks, then you get to train all of them, then you pick the right one. Or if you're working with images, how does it know that, okay, you have trained the model, then you have fed it some photos to try out. How does it determine that, okay, this is the right one and not the other one? So there's some decision theory that is involved in that working on the model. Then we see some information theory. Okay. Also, on number 11, we have the optimization, which is a very essential skill, okay, part in the ML model curation, because you're talking about concept generalization. How does it work with new data? How does it experience and work its way around with new data and so on? Okay, then we get to the fundamentals now. Now, after you've gotten these basics, the math behind there, because, okay, sometimes it might seem, okay, why should I care about knowing this mathematics? Sometimes you have your model that is not performing very well. You can fall back to this to do what we call debugging, sorting out where possible errors, where did they come from, so that you can actually, okay, fix them as you go your way. Then we'll be having the fundamentals now. Now that we have covered the foundation, the mathematics, and the decision theory, and so on, now we can start on this unsupervised learning. Okay, the supervised. Okay, these are supposed to be supervised learning. Then we get to the unsupervised. We see the clustering algorithms and so on. Semi-supervised, we see the techniques and so on. Now, then we go to the deep neural networks. First, before we specialize, we introduce you to neural networks, the architecture, the history. How did it come by? Why was there a need for it? We'll see there's a field that is springing up called neuromorphic computing, where engineers are trying to model hardware circuits based on how the neuron of the brain actually works. Because for the brain, okay, not the exact figures, but they have using like some little bit of words to get you running a whole body. Human being
60 watts runs the whole brain.
Yes.
Compared to Azure data centers that require atomic energy.
Exactly. Yeah, those guys are building large energy reserves for the same thing. So what if we model circuits that can use little amount of power for the exact for the greater computational capacity? Then now after we have covered everything else and gotten into neural networks, then we can now people will get to choose which track would they prefer to, because for the bit about ML, you see it's a lot. You can either go the image processing way, you can either go the human language processing way. There's a lot. So in this case, we are going to find a way. I know there are going to be guys who will be very excited to learn either of them. So we are going to structure them in a way like, okay, let's say Monday is the neural net. Okay, the computer vision track. They are having their okay. Monday you have the general example. You have the general session. Then Tuesday is those guys for the computer vision track are having their session, so that guys who are in LLP but might want to get a gist of what CV is, they can just drop by. Then we get to the non-parametric models. Okay, that's a complex. Okay, that's a general word. Basically, what is going to turn out later is that really those are just, you have read those books. Okay, they are funny books that you see, for in our case, the author on the preface, he said that rather than focusing on the esoteric, nice terms in mathematics and so on, we are very focused on the applicable bits about the mathematics in our case. Instead of, you see that we will not be focusing on the fancy words rather than what this is a very critical component, as you will see later, the K nearest neighbor classification in very suitable. Instead, don't focus on the non-parametric big terms and so on. Then you see beyond supervised learning, where we teach you now those tricks on how do you work with less data. How do you do feature engineering? You have a data set, let's say example 50 images that you're trying to predict, is it a cat or a dog or something? A simple example to that. We'll teach you the feature engineering skills, like, okay, let's say you can now rotate that cat to be 90 degrees north, 30, 40 degrees elongated, elevated, so that it kind of looks different. So that the model, when you input an image of something, another photo that is oriented 30 degrees, elevated or some, okay, or screwed some, sheared to some level, it can easily detect it. Okay, then we go about the recommender system. How do Netflix work? Because we see the distributed recommender system. What Netflix shows you in Kenya is not really the same thing that an American in Texas will see. So around those things, I think that's a general overview of the same. And Mr. Andrew, does it give you a sense of what you can expect, or I dive in deeper?
Thank you, Mr. Jacob. That was very informative. Did you ask? Mr. Andrew, you wanted to say something?
Oh no, sorry, I was saying thank you for the breakdown. I think that answers my concern, yeah.
Okay. Then I think I saw something on the chat.
Jacob, probably as you close your screen, I'll answer a few.
Okay.
So that you, so Dr. Stroke, Mr. Ibrahim Mohammed, thank you for your question. Is there an option for paying fees in installments? So just for 1 minute, I'll say from our previous cohorts, we also learned a few things that most of the time, there's usually needs to be a commitment from the other side as well. So what we can say is that maybe we can allow for probably before someone enrolls to the class, we could then take maybe half of the fee paid as a sign of commitment. You will see studies, let me not say studies because I cannot quote them, but we have observed anecdotally that people who pay for these challenge sessions end up coming for all, if not most of the sessions. They end up building a beautiful capstone project because they have paid their money, so they're a little bit serious. In the past, we gave scholarships to some students, and they ended up not being, there was no opportunity costs. So we encourage that at least if you want to pay the fees in installment, that might be welcome. We can work something out, but at least have 50% down payment will be good. That would be nice. So another question by a colleague, Theory, what is the payment plan? So again, I've said you can do it in installment, but we can of course work something out. But I would prefer if individuals make a significant commitment, because you will find that once you pay money, you will come to class. You will see the body will not allow you to just pay money and then not come. Then what specification, what laptop specification? Mr. Jacob is going to give more, but we are going to do, Jacob, probably you might be preparing the notebook.
Okay, maybe I can even show them right away.
Yes,
so that,
go ahead, so that they can be able to see. So we, as he's sharing screen, maybe we during the time you'll be doing VS Code installation and GitHub Essentials, you might need a laptop, but eventually we will just be doing a cloud. There is nobody in this session right now who has enough compute in his laptop, maybe except Jacob. But and you might, if you are doing a good enough model, you might need cloud compute. So Google, there are various credits given to students and educators, like Google Vertex AI, Google Cloud, AWS, etc. But so you may not need to worry exactly about your laptop, but you might need to, maybe as you practice GitHub, etc., you may need a small laptop. Jacob, go ahead, take over.
Okay. Really, okay. As Dr. Sianya has mentioned, most of the, when you're doing hardcore machine learning, really, a typical laptop will take you 40, okay, we can say 100 of years to get your model running. But Google has provided some a resource where you can just give you some a notebook where you can write your models, run them, and they give you some bit of computing power. So maybe I can do this. You can see here, you can connect as long as you have a Google account, and maybe your laptop might even be 2 GB of RAM or some sort, but you don't have to worry about that. Google gives you free resources here. You can come change random type. Then you see it has a CPU, even a GPU. Okay, this is a graphics processing unit. For those guys who have heard about this company, NVIDIA and so on, the GPU is mostly used to this high computational processes. It gives you free of them so that you can just run your models here. Then maybe a bit thing, we of course will introduce about the VS Code later, but for starters, you can see, let's give me an example of my notebook. You can see from the first point here, we have the text, the notes, and so on. Then things get out of hand here. Okay, not out of hand per se, in a good way. You can incorporate your notes and your playground on the same notebook. So you can see here, you can, as we'll be doing the code, you can come here, write your code and run them, run everything. So example like that, and it does the running of the program, and you see the output on the same notebook. Mostly, okay, this is what we'll be sharing, the material resources, this is what we'll be sharing with you. We'll be having the notes and everything on this notebook. We share the notebook to you so that you might suggest that, okay, now I want to call this a different variable name. You can play around with whatever you have provided. You just do your things here, and nothing will be broken elsewhere. So really, you don't worry about the computational power of your laptop. Yeah, I think that's it for me. Dr. Sen, you can proceed.
Thank you. Also, for, I think, Mr. Anthony, you know that in Python, we have environments where you can have multiple environments in the same machine. So also in the cloud, you can be able, if you maybe have different projects, messing around with one project may not affect the other. And in any case, if you're ever to build something remarkable, you probably might not host it on your machine. So Andrew, you can go ahead. Dr. Kasembeli, you can go ahead. All right. So also on the chat, so I think Jack Onyango will share the detailed program once it's finalized. Maureen Charango, when is the next intake? We are intending to do it in cycles based on the feedback, and probably will announce the next cycle in the middle of the summer school. But we said that there's no day like the present, so we'll probably now focus on the current summer school so that we make sure our students get the best value for their money. But I'll probably get back to you on the calendar of events for the next year. Any minimum requirement for computers, you have raised that. Are the lessons going to be recorded so that someone can watch and listen to them at their own convenience? Yes, they are going to be recorded. However, there's something we probably will need to note. There will be practical seminars in the afternoons or evenings. But remember that because as we are committed full time, we'll be able to be having breakout rooms spread throughout the day based on the tasks that are allocated. So we might have an end of day seminar where all of us come to the class, the so-called 2 hours, but during the day, especially for those who want to delve into the technical details of the implementation, then we'll be having spread out classes that will be done PRN. Then the costs for Manani, we are saying that the total cost is 30,000 Kenya shillings, so $233 US for foreign students. And from the feedback we're getting from the users, we might discuss installments. The classes, as probably Jacob is going to highlight later, we are hoping to have classes in the evenings for the webinar, like the live classes, but then we might have discussions based on tasks and assignments and projects that will be spread out as the teams agree on. I think I've said that. Are there any physical sessions? Currently, we do not have physical sessions, but we are going to have coding and coffee sessions that will be announced from time to time based on the logistics we'll discuss with our partners. Yes. Mr. Jacob, would you want to add something?
Okay, I think I've seen another one. What's the duration of the whole program? Maybe it's 4 months, starting January up to ending April. Then I see Mr. Andrew, your hand is up. Yeah. Do you have any further questions?
No, I'm sorry about that. Apologies. I think I left it like that for a while. Pole.
Okay, that's okay.
Okay.
Okay. That's it for me. Now I think we'll be having some summer school sessions from now until we get to the start of the summer school. We'll be sharing some things here and there to get you started for the curiosity, satisfaction, and so on. Until now, we kick it off from 6th January 2025. That's all for me. See you. Happy learning.
So I'll take over from here. Thank you so much, engineer, for your wonderful presentation. So there is a small question. Mr. Adam has asked if the program will be self-paced. Indeed, it will be self-paced. Tasks will be given in the beginning of a sequence of sessions. Then each session will be now practical. People presenting what they have found, challenges, what they have found on research. We'll also be having some course material that the facilitators will be doing. So there will be the guidance will be coming from faculty, but the tasks, you can complete the task as quickly as you can learn it, because I know many of our students will also be either employed or students learning other full-time courses. So before probably we disperse, allow me to share a message from the sponsor of today's session.
Okay, sorry, Dr. Senyo, I think Mr. Ibrahim has asked if we will issue a certificate. Yes, we'll be issuing that electronically so that you can share even to your social profiles. Okay, then Doc, you can proceed.
So thank you. Good. What is the final output of the course expected? So one, our students are going to share their final industry-ready products on either on their domains of their choice or open source code on GitHub, depending on what problem they picked to discuss. Jacob did not mention, probably I'll mention in my few remarks, there are some research projects that knowledge from our ML challenge is going to guide. For example, automated brain segmentation for discovering the physiology and interventions that are required for diseases like Alzheimer's. That's probably what I'm going to work with the team that will be allocated to me. So the output might be the solution that the students will have made based on the problem they picked in the beginning of the course. I don't know if that is okay with you. Mr. Kamau.
Yes, hi. Yes, I think it's good. So basically, what you're saying is that it has to be something that is a use case that sort of works wherever you probably are or hope to work.
Yes.
So maybe a follow-up question is, whatever platform will be used will be free, most likely, when if you host this or deploy it in whatever forum.
Yes, so depending on if our students work on a project, for example, just an example, if we work on a brain segmentation software or an algorithm, from, for example, what I'm going to develop with my student, we'll probably publish a paper or two. Then now that code will be on GitHub for all progeny to use. Then of course there'll be my students or co-authors will be cited for, because brain segmentation, image segmentation in healthcare is becoming a big thing, yet the African expertise is lacking. So whoever wants to have a project on brain segmentation or lung segmentation et al. might recruit those students for any other projects.
All right, thank you.
Thank you so much. So before I give you a message, I wanted to tell everyone that AI is not a fad. AI is here to stay, and AI is going to help us create abundance in our society. And what I'm observing in our environment is that we are leaving AI again to those people who have abundance already, and we as Africans are not exploiting its full potential. And because of data protection laws that have been instituted by our society and government, we may need to have native applications locally that can be able to serve our communities at a very small price. Because if you are going to depend on imported AI tools, they might be out of reach for most of our society. So I am welcoming all of you guys to come. It's not as hard as, I'm sure there are things that you do in your day-to-day lives. If you are surgeons, if you are doctors, I saw an infectious disease specialist there. You do way difficult things than what you are going to learn here today. So it's just commitment for a few weeks. Then you'll be able to get skills that you can apply in every other field that you're working on. So people want problems. We'll teach you how to do questionnaires, to do market research, so that you can get problems that people want, and then you solve for them. So we are also hoping that one or two of our students will work on omics. That's an area that is coming up, that we really hope that our community will be able to benefit from the work that we do here. We're hoping to partner with organizations in the audience who might want to integrate AI in their business practice. At Rastuc, we hope that we can be able to build custom solutions for them that can be able to help them streamline their business processes. You can also side chat so that we can give you a solution for that. A more detailed program is coming. We'll be recording these sessions for those who might need them. And the syllabus might evolve slightly based on where we see the gaps that we find as we interact with our students, so that we can be able to customize something that will make our students be able to achieve what they want. Now, just a message from the sponsor. So today's session was powered by Rastuc.com. That's our sister company. And by the way, if you have an organization that might want to pulse messages through this platform, we encourage you to onboard us. So this is a platform that it's a care discovery platform that uses artificial intelligence, of course, to match patients with their care providers. So I do not know who is in the audience. If you are a provider, if you own a hospital, a pharmacy, a lab, an imaging center, you'll probably click for pharmacies and join the wait list so that you can index you, so that patients who are looking for your services can find you. If you are a doctor, you can come to this page for providers and set up profiles so that patients can book. Here is an example of our doctors who have actually used the system before. Then, so we onboard all healthcare practitioners, but probably for patients, those who are not doctors, you can come get any service that you need. So go check it out. It's rastuc.com. I don't know if you're able to see. Probably I should type it so you can go and try it out and see. Okay, thank you so much for your time. If there's any other question, this is a good time to share it, or any comments. All right, Mr. Javan, are you back?
Yes, Doc, I'm here.
All right. Do you have any comment for our students before we adjourn?
Yes, so all I have, okay, so first, my name is Javan Otieno. I'm the COO and co-founder at Rastuc. I'll also be, additionally, I'm a computer scientist. I'll also be taking you through some of the lessons we've seen there. And I'm looking forward to seeing you in class and you guys learning a lot from the sessions. So, thank you.
All right. Thank you so much, guys. Reach out in case of any adjustment in, or any other partnership that you might want, either on WhatsApp or on our email that is at info@rastuctechnologies.com. Thank you so much for your time, and see you in class. We start our preview classes on Monday. Thank you so much. Hello, Bonke, Arunga. Did you
Yes,
have a
how are
question?
you?
Did you have a question, sir? I was hoping that you join early so that you tell me you're a HMIS developer.
Yes. Sorry, I
Totally.
joined late. I am doing night shifts right now.
Okay. You are someone of interest, of significant interest to me.
Okay, I'm happy about what I've had so far. Things are going well.
Okay. So we'll probably work together. Kuja, come here. We build our community.
Sawa. I am available, very available.